Welcome to RBB's third Lunch and Learn in the series, How to Save Money in a High-Mix, Low-Volume World. With us today, Jim Thompson and Bob Keisler with National Tech. They'll be talking about saving money on bareboard costs.
My name is Jim Thompson, and I have 43 years experience in the circuit board industry. The first part of that was in manufacturing, learning the ins and the outs of this industry that's forever changing and evolving. But I moved into sales and then sales management, and I'm the sales manager for the Midwest region for National Technology Incorporated. Come Saturday, I'll be celebrating my 18th year with National, so I've been with them quite a few years, and prior to that I was with another manufacturing board maker for almost 20 years. So it's been an interesting industry and learned a lot, but Bob is our general manager and president of the company, and he is our technical guru. He also has 39 plus years of manufacturing and experience. So between the two of us, we have over 80, but I learn from him every day. So whenever I get a chance to participate in something like this, it helps to stay on top of the changes and the advancements of our technology. So without further ado, I will pass this over to Bob.
Thanks, Jim. Yes, my name is Bob Keisler. I've been with National for since 1995. As Jim said, 39 years in this industry. And what can we say about that? We're here today to learn about saving money and what we can do in the beginning stages, what we can do as we go through, as we purchase, some purchasing techniques that may help us save some money. And the big one in the middle, panel utilization, trying to get the most for our buck when we design a board, when we design an array, and when we build a board. Basically, we're building a panel and we want to get the most out of that panel, which is going to save you the most money. Okay, so we're going to start here in the beginning is talking about designing a board and basically what is a standard board and what adds money to a board. Over the years, many things have changed. We come up with new terminology, filled vias, cap vias, blind vias, buried vias. One thing that hasn't changed is basically what we consider a standard board. If we need filled vias, we need laser drilled vias, we need colored masks, then by all means we have to use that. But if we don't need that, that's where we can save some money. So what is a standard board? When I go back to 20 years ago, 30 years ago, what we called a standard board was pretty much, again, the same as we do now, with the exception of lead-free. A standard board was, 062. It had standard material, 1 ounce finished copper, what I'll call moderate for the time, pad size and line width, although that's changed through the years. Green mask, and we usually shipped in 15 days. Things that are going to add cost are going to be, my list right here. It's going to be things like board thickness, higher copper weights, controlled dielectrics, specialty laminates, mask colors will add cost, final finishes, obviously layer counts, and all of the add-ons, blind vias, controlled impedance, milling, plated edges, and of course the density of the design. When we talk about 3 mil, 4 mil lines, that's obviously going to be a cost adder, as well as everything above there.
Hey Bob, is density of design on that prior slide, is that the last line item?
Yes, it is.
Okay, I just want to make sure I was capturing the full screen there. That's all. Yeah.
So to go through thickness as being one of the cost adders. Again, most of the boards I'm sure that are being purchased by this group here, being designed by this group, majority being is typically 62 thick. And if we use that as a factor of 1, we can see that thickness is going to drive up the cost being thicker, and also it can drive up the cost when we go thinner. Reason being is on the thinner side is going to be that typically we can't run as large of panel formats, and then it's more difficult to process. When we go thicker, we don't get the same drill stack height. We don't have the same route stack height. It costs us more to manufacture because we can't process as many as a time. But the biggest problem there is going to be the cost of our actual laminate from our supplier. This does differ with standard TG versus high TG, but there's obviously going to be a big increase when we go up to the thicker laminates. If we can stay with 62, if the fits your design, that's where we need to be. Copper weights, it's a metal, it's a commodity, it's expensive at times, goes down at other times. Probably one of them things that we only see it go up and our suppliers don't show us when it goes down. But there is an upcharge for anything greater than 1 ounce. Typically 1/2 ounce and 1 ounce are going to be the same price. And when we get into the 2 ounce or 3 ounce, there would be an upcharge for copper weights.
Hey, Bob, I'm going to jump in. It looks like Jay Wheeler has a question in
Sure.
the chat for everybody. He's asking, are there tools to help coming up with an optimal array / panel size for cost?
Yes, there is. And I do have a couple slides on that further on in the show. And we can certainly discuss it at that point. There is, I have some examples and a couple things we can do there. So we'll make sure to hit on that.
Great. Thank you.
Laminate adders. When creating controlled dielectrics with a multi-layer board, uncommon cores can cost extra. And what's an uncommon core? If we went to any of the board shops in the area, in the States, I should say, we're going to find 5-core, 8-core, 14-core, 28-core, 62-core is going to be on mostly everybody's shelf. Very common materials. The 5-core is used in a 10-layer, 8-core and an 8-layer. Typically use 14-core and a 6-layer, 28-core and a 4-layer. And of course, our 62 is our double-sized boards. Common materials, everybody's going to get the best price on those, and we're all going to have it readily available. When we're designing a multi-layer that may have to have some controlled dielectrics, there's a list there, the 4, 6, 10, 12, 18. These materials, if we don't have them on our shelves, our supplier's probably going to have them on their shelf. So it may not be something that is readily available, but it is available. And again, if we can stick to a standard design or let the board shop give that design, that's just going to save time and possibly some money because we don't have to expedite material in.
Another question from Dalton. Is it better to panelize yourself or should you rely on the PCB vendor?
I'm going to say that I would let your PC vendor do it. Reason being is we're going to be looking for 2 things. We're going to be looking for our best panel yield, which is going to give you the best cost. Where we lack on that, though, is going to be we don't know your process as well as you do. So when it comes to if it was a tab and route design, where we put the tabs may not be where you want the tabs. And if we made the board too flimsy, if you will, because we don't know the weight of your components or everything else. So if we are designing it, we're going to design it for best price and best panel utilization. But we also need your approval that it's going to fit your process.
It also helps if you need tooling holes, or if you need fiducials on the array. We call them arrays. We build panels. We supply arrays to our customers, and each array could have as many as just one daughter board, or it could have multiple daughter boards on the array. But it's kind of like a controlled impedance. When we're doing arrays for customers, we kind of want to work together with you so we can maximize the efficient use of our material, and therefore giving you the most, making sure that you derive that benefit by getting boards that you're paying for. So, and we're throwing away less scrap. So rails, thickness of rails, how many rails, do you need them on 4 sides or just 2 sides, and fiducial and tooling hole locations if necessary. Those are all things we need to know. We can't assume, but it's a collaboration, and but it's ideal if we can generate it, because we know how many of those arrays we can fit on a manufacturing panel, delivering product to you.
Okay, some other things that can cost money or building cost is the type of laminates we choose. And the laminate types 4101/21 is the IPC designator. The 4101/21 is a laminate that's been around for a long time. It's our 130 to 140 TG laminates. Been around before RoHS, although it is RoHS, it's really not made for lead-free processing. Still widely used. There's still a lot of boards that are non-RoHS. But if we do go for a RoHS and want that material that's going to withstand lead-free assembly, the 4101/126 is going to be the material that would be called out. There's other slash marks. Some people specify it as /126. Others just say that it needs to be a 170 TG material. Some call out a TD of 340. And some people even just put on the print that it needs to withstand lead-free assembly. What we don't like to see, or what we should avoid, is specifying a specific vendor or material unless that's definitely required. Isola has done a great job of marketing their 370HR. I see it on a lot of prints, but it would limit us to using that laminate. And there is equivalence. So if you put on a print that we need vendor's X material, if it's acceptable that an equivalent would be okay, then please note that, because that does save some costs there. Mask and legend. Yes, there is a difference in costs even in the solder mask. Green has been around for forever. When we buy green mask, we buy 500 to 1,000 kilos at a time. When we buy blue mask, we may be buying 10 kilos at a time. So there's obviously going to be a cost difference on these colored masks, and most of it's just because of purchasing volumes as well as manufacturing volumes when our suppliers create it. White legend is typical, although we do other colors. Black is another color that's done often, but in our case here at National, we have a legend printer that does white, and we have a guy named Harnish that does black. He's going to be doing it by hand. So a lot of the colors, odd colors, are going to be done manually, where the white is typically going to be done on a legend printer. Sorry about that, I triple hit here. Next thing I want to go with is finishes. The next 2 slides here just kind of show the cost of ENIG versus the standard would be just your typical solder. ENIG is definitely going to be a better finish. ENIG is going to be our top choice of finishes when we need coplanarity on the pads. We need our pads to be flat. It's got a good shelf life. The handling is not as critical as it is with silver, but there definitely is a cost there. But if we look at the cost on a 2-layer board, which again, the gold being is going to be a hard cost, it's a big percentage of a 2-layer board. But when we get into higher technologies, it's not really adding that much to the price. This is just saying if a double side board was $10, the gold may have been, if the gold could also be a cost of $5. It's going to be 50%. But that same gold on a 12-layer board is still only going to cost $5, but the board is going to cost more. So it's a much lower percent when we get into the higher layer counts. At the end of the day, you have to have a finish that's going to do what you need it to do. Solder is not going to be the best option for our tight PGAs and tight surface mounts, and it's a cost that may have to be absorbed. So if we can go with a lower cost of solder, that's a good option. If not, silver's your next option cost-wise, and then the most expensive of a standard finish is going to be ENIG. The next finishes that are a little bit more here, the hard gold. And when I'm talking hard gold, this could be the actual hard gold that's used on contact switches, tab gold, which is going to be for tab plate gold. And we can also even throw in the Enipig and soft gold because these are mostly outside services. And outside services, I usually say that the only person that makes money is going to be UPS because the product has to ship back and forth. And as a board manufacturer, it's not where we're making our money because we're paying this extra service and also the extra shipping. So,
Hey, Bob, it looks like we got another question. Dalton is asking, is HASL considered standard?
That is correct, yes. Yeah, HASL is hotter solder level, and that would be a standard finish. It's going to be your most economical finish, but again, it has to be applied on a board that fits that design. Tight PGAs, tight surface mount pitch is not going to be the best option for the hassle finish.
And that does also come in lead-free as well. You can get lead-free hassle and standard hassle, which has got the lead in it. And we do ENIG inside. We do ENIG inside. I just saw that question.
Okay.
We do not outsource the ENIG process. ENIG stands for electroless nickel gold, by the way.
Okay, so price factor by layers. And again, this is part of design. The only reason we go to 4 layers because we need to. We go to 6 layer because we need to. But each one of these adds cost. If a 4 layer could be a little bit bigger and prevent you from going to a 6 layer, obviously there's going to be a huge cost savings there. If we can keep it to a 6 layer instead of jumping up to an 8 layer by changing something. Again, trying to do a different piece size or maybe a different layout that keeps us that layer count down. By reducing line widths, by reducing pad sizes, there's going to be a point there that's going to work the other way because of the density factors. In other words, if we went down to a 3 mil line in space to keep it a 6 layer instead of going to an 8 layer, by reducing it to 3 mil line in space, now we just increase the price the other way. So when I'm saying try and keep the layer down, but we also still have to stay within a moderate design, meaning a 5 mil line in space, 16 mil via pad or greater, 10 mil finished vias and greater. So with the slide here showing the number of layers, the other part of this, as I said, trying to prevent jumping up a layer if we can, is getting a little bit more involved, is going to be blind vias and such. So the diagram on the top here is it's an 8-layer board. This is a typical design for some 8 layers with blind vias. It would have a sub from 1 to 4, a sub from 5 to 8, and then we're going to do it again as 1 through 8. The cost comes in on blind vias, and I touched very little on this in the beginning, but the blind vias, filled vias, these extra things, what this really is extra processing. So in order to build this board here, we have a sub that's basically 1 to 4. So we're building a 4-layer board. And then we have another sub that's 5 to 8. We're building another 4-layer board. And then we're going to put them together, the 2 subs together, and drill 1 through 8, which means we're building another 8-layer board. So in essence, and this is where the cost comes up, we've built a 4-layer board, and then put them together, and we're building another board. So point here is if we can, if let's say that was a 10-layer instead of an 8-layer, and we didn't have to put those subs in, we didn't have to put the blinds in, whether we had more room to move something, a 10-layer versus building a 4-layer, and 8-layer is certainly going to be much more economical than that 8-layer with the blind vias. Okay, next is controlled impedance. We talked a little bit on the arrays, which we'll get into a little bit more of. Should you have the board supplier help you do the array, or was it better to do it yourself? It's a similar thing with the controlled impedance. We have a software system here, as many board suppliers do, is called Polar. It's a very sophisticated and expensive software for doing impedance. We can definitely help with the design. In other words, we could do an impedance with you and letting you know what your stack up is before you finish the design. And what we don't want to have is a design done and then we're trying to fit 50 ohm impedance or 100 ohm impedance into a design that's already done. What ends up happening is we end up with odd materials, we end up with odd dielectrics because we can't change the line. Can't change the line with our materials because that design is already done. So if you knew it was a 5 mil line you needed for 50 ohm impedance, or we needed a 5 mil line and 8 mil space for 100 ohm impedance, and we used the dielectrics that are off the shelf, we're going to save money that way. If it's already designed and I can't use standard dielectrics or standard core material, that's where cost comes in. Score versus route, it's kind of a small thing, but it does add cost in there, especially over time. A score is where we're going to snap a board apart, and a route is going to be the routed breakaways with the tabs on them. With a score, the key thing is it's got to be rectangular. It can't have a radius at the end, typically. It needs to be square corners and a rectangle, and your scoring is going to be your most economical way to cut them out. When we do tab and route, basically it's a cutting machine, a milling machine, a router that is going to plunge into the board. It's going to cut, it's going to lift, it's going to go and replunge, and it's a very long operation compared to a score. So again, if we can do score, If it is a rectangle, that's going to be the best option. The things that prevent score is going to be odd shapes or radiuses. Obviously, we can't do with a score blade. Router size, again, it's kind of tied into the previous slide. And this gets into the size of the cutting tools. Normal routes, if it's a 93 route or 100 route or 125, it doesn't make much of a difference. It's when we get down to these small cutting tools that we have cost added into the board. When we're cutting with an 031 radius or router to get an 016 radius, that router bit is gonna wear out, within a few feet of cutting, compared to a 93 that's gonna last a lot longer. So when we get down to tight radiuses on the board, sticking with the 45 radius is always gonna be something that's gonna end up saving in the long run. Oh, here we go with the race size. So we talked a little bit on this earlier, and we can elaborate a little bit more here now. The best array size for us, and I think yourself, is typically around 8 by 11. An 8 by 11 is going to fit 4 up on our 18 by 24 processing panel, and that's a very common panel size within the industry. So just to show the difference, instead of 8 by 11, if it was 9 by 10, instead of fitting 4 up on a panel, we would only fit 2 up on a panel. And you can see right there where that would definitely add cost. The array is probably one of the biggest cost savings that can be done. It's one of the easiest things that can be done if it fits what you need at the end. Meaning that if you can live with fitting your panel into an 8 by 11, or I do have some additional sizes on the right hand side there. If it fits into one of them sizes or just slightly smaller, that's going to be our best panel yield, and that's going to be your best cost at the end. As far as us doing that, what we need is good information from yourself. Jim, I think you touched on this too, is if wherever your tooling holes need to be, wherever your fiducials need to be, if you have special requirements that you need for your array, then we need to know that in the beginning. It will certainly help you with the best array size for the best price. A couple hints were to avoid or use smaller arrays on thinner boards. If it is something that's in the 25, 30 finish, we want to use a smaller array so it's not sagging as much as we go to cut them out. And also you don't have issues when you go to assemble. Avoid scoring thicker panels, and this is just because of the mechanics of scoring. As we're trying to cut that material out, we're going to have extra wear and tear on the machine. It has a hard time cutting through the 125 thick material. May have to go once or twice through the board to actually get it to score. Okay, deliveries. Again, if we have to build a board, I think yesterday we did 3 24-hour turns. If you need it tomorrow, we can certainly do that. During our COVID times, we had several orders. We started in the morning and shipped that night. Boards were emergencies. They had to have them the next day. We came in, started boards, and they were on the UPS truck that same evening. Definitely adds cost, and if you want to ship today, it's a lot of cost. So if you don't need it till next Tuesday, then that's what we should be ordering it for. Nothing bothers me more than walking through our maintenance department and seeing a UPS red sticker on a motor that's still in a box that we got a week ago. So if we need it tomorrow, you need it in 2 days, 3 days, that's the way we should order. If it can be a 5-day turn or a standard 15-day turn, then again, we should order it that way. There's also times that weighing out shipping charges of shipping overnight versus a 2 or 3 day shipment that may work both ways as far as doing a premium and shipping it ground, or even shipping a standard turn overnight to still make your date. So it depends on the weight and what you really need for time. But again, if you need it tomorrow, we can build it. If you can wait till next week, it's obviously going to save cost. So max for min is something most board shops also offer. It's what we call our minimum lot charge. Just an extra way to get a few extra pieces at times. We're going to build up a certain amount. It's typically about a panel's worth, and we would put that on our quotes, how many pieces that we would be able to send you for the same chart. So in other words, if you needed 2 or you needed 10, they're probably both going to be the same cost depending on the board size. So if you can take the 10, they're either going to, they'll possibly be sitting on your shelf, or, maybe it's something you can use if there's further delivery. Okay, Kanban. Kanban's a way of just having boards sitting on our shelf instead of having to order them for being built. This is typically done with mature designs. It's something that we would build up, and we're gonna, what we typically would call a bin, we're gonna build up a group of 100 boards. They're sitting on our shelf. When you ask us to release them, we ship those to you. We start another 100 pieces and have them on our shelves for the next time that you need them. Again, Kanbans are shipping usually within a couple days of when you request them. It has to be done on a mature product because we're always going to have boards in process. And it's important to define your expectations with the board supplier, and actually between us both, that who's responsible for what. So we want everything to be clear up front, and it's certainly a good way to have boards ready whenever you need them. Okay, know your supplier. This is also the big one here. One of my comments was you don't want to bring your Chevy to a Mercedes-Benz dealer's repair service because of they may not know what they're doing, or both ways. Know your supplier's capability. If you know that we're not capable of doing something, then it saves you time and saves us time in quoting. And we should know that. We should have a capability understanding of all your suppliers, that we're not wasting time sending us a board that has micro vias that we don't build, or sending something that doesn't fit us that would be a no bid. I put in there shops that may do a 20 plus 30 layer boards may not be your most economical fit for a standard 4 or 6 layer board. Again, on this, it's putting the board into the right hands. If we can, if it's a board that fits national, we're going to be quoting that the most economical way. If it doesn't fit us, it's not going to be the best option. And I think knowing each one of your builders or each one of your manufacturers will help with that. It'll save you time. It'll make sure that you're putting the boards into the right place.